Hello. Today we're going to be looking at the Pythagorean Theorem. The Pythagorean Theorem says that the square of the hypotenuse is equal to the sum of the square of the legs. And that's what it says. Sometimes it's written a different way, where it'll say the sum of the square of the legs is equal to the square of the hypotenuse. That is the Pythagorean Theorem. One of those two ways. It's never been written any other way. However, a lot of times in textbooks, they use something different. And many of you probably know what it is because it's usually the most common thing that people actually remember from their classes, which is completely fine. The reason why I am going to try my best to not say that is because oftentimes people will mistake one of the sides because of a formula they were told to always use for the Pythagorean theorem. So I wanted you to get used to looking at it in terms of legs and hypotenuses. So I have these three sides here, labeled A, B, and C. And first of all, let's talk about where the legs are and where the hypotenuse is. So generally speaking, people tend to find the hypotenuse first. The hypotenuse will be the longest side of it. So don't go by what looks like it's longest or whatever like that. Go by the fact that the side that doesn't touch this right angle is the hypotenuse. So here's my hypotenuse up here. Okay. Now, the other two sides then must be the legs. Remember, the legs of a right triangle are what form the right angle. So this is a leg, and this is another leg. Okay. Now, from translating our word problems into an algebraic equation, we know that we can read this statement here. We can read the Pythagorean theorem and come up with an equation for it. Well, it says the sum. It says the square of the hypotenuse. So I'm gonna take the hypotenuse and I'm gonna label that HYP instead because I don't want to spell out hypotenuse a lot. So the square of that, so hypotenuse squared, is going to be equal to. It says the sum, meaning we'll have to add two things together, of the squares of our legs. Well, I'm gonna call the first leg L1. I'll call the second one L2. So it says we're going to take the sum of these squared, so to the second power. Okay? Well, we have variables for our hypotenuse and our legs in this instance. So in this case, our hypotenuse is A. So I'm going to call it A squared has to equal our two legs squared. So I'm going to do B squared and C squared. So A squared equals B squared plus C squared. Okay? So I got this, though, based off of what the variables were for my sides. So my hypotenuse was called A, so that's why it's A squared equals, and my two legs were B and C, B squared plus C squared. Okay, so that's how we're going to begin this. The Pythagorean theorem is the square of the hypotenuse is equal to the sum of the square of the legs. And this only works for right triangles. It only works for right triangles. If it's not a right triangle, don't try to use this. Okay? All right. If it's not a right triangle, do not try to use this. Okay, so let's see what else we can do here. Let's look at some more examples, okay? Let's put some numbers in here. So let's say that this side length here is 3. And let's say that this one is 5. And I want to find out what the other side is. I have no idea. Let's just call it x. So if I want to find out what x is, what would I need to do? Well, first of all, I would want to have to set up the Pythagorean theorem. So if we set up the Pythagorean theorem, we know that the square of the hypotenuse, well, where's the hypotenuse? Again, that's actually where we should start off, by labeling the sides until you get used to recognizing it automatically. The hypotenuse is, again, the side that is not touching the right angle. So here's our hypotenuse. And then here are our two legs. Here's leg 1, and here's leg 2. Okay, so the square of the hypotenuse, so 5 squared, is equal to the sum of the square of the legs. So 3 squared plus x squared. All right, good. So from here, we can simplify our expressions. So 5 squared would be 25. 3 squared would be 9. And x squared is still just x squared. Good. Well, how do you solve for the unknown? How do we solve for x? Well, this is going back to algebra. So in order to solve for x squared, we first have to isolate it or get it by itself. Well, what's happening to it? Well, the last thing we would do with x is after we square it, we would add 9. So the inverse operation of adding 9 would be subtracting 9. So we can subtract 9 on both sides. And we end up with 16 equals x squared. Okay, well, good. How do we solve for x at that point? Well, if we know that 16 equals x squared, I can get rid of the square by taking the square root or raising it to the 1/2 power, whichever you're most comfortable with. So if I take the square root of both sides, we end up with 4 equals x. Now, as we talked about before, when we take the square root of a variable squared, we didn't actually get a positive and negative version of our answer, because in this case, 4 squared is 16, and negative 4 squared is also 16, because negative 4 times negative 4 is 16. Why do we want just the positive version? We're talking about measurements and lengths of sides. Does it make sense for our length of a side to be negative 4? No, it does not. It makes sense for it to be 4, though, so that's what we're going to use. We're going to use just the 4. And so for when you're doing your mathematics, as long as if your final answer comes out so that you have a reasonable answer, meaning that it comes out to be a positive length in your final result, then yes, that's the one that you would use. Okay, so in this case, we end up finding out that the other leg was 4. All right, great. That's how we can use the Pythagorean theorem to solve for a missing leg. All right, let's see what else that we can do with the Pythagorean theorem. Well, we can find the hypotenuse if we know just the 2 legs. So let's give some other numbers here, shall we? And in fact, I'm actually going to erase this. So go ahead, copy it if you need it. Pause and copy. Okay, I'm going to erase this and draw it a little differently. The reason is because a lot of times people think that the right triangle is always drawn like that, and it's not. There are lots of ways to draw right triangles. So I'm going to draw this right triangle here. And I have to find that to be a right triangle because there is a right angle and only one right angle. So I am going to say then that this side is 5 and this side is 12. And we want to find this side here. Well, let's label our sides first. So from here, I know that the 2 sides that form the right angle are the legs. So 5 is a leg and 12 is also a leg. That means that x has to be the hypotenuse, which it is because it's not touching the right angle at all. So this is my hypotenuse here. Okay, so from here, I can use the Pythagorean theorem to set up an equation to solve for the unknown. So I know that the square of the hypotenuse, or x squared, in this case, the square of the hypotenuse is equal to the sum, so I'm going to add, of the square of the legs. Well, my first leg is 5, so 5 squared. My second leg is 12, so 12 squared. So I end up with x squared equals 5 squared plus 12 squared. Okay, so let's solve for the unknown now. Well, let's simplify our expressions. So we get x squared equals 5 squared. Well, what's 5 squared? 25. Right? What about 12 squared? 144. Excellent. Okay, so from here, we get x squared equals, we can add those two together, 25 and 144 will be 169. Okay, so how do we solve for x at this point then? We have x squared equals 169. Well, to get rid of the square, we would do a square root. And whenever you're using the Pythagorean theorem, you will at one point have to use a square root. So just be used to that fact. So we take the square root here of both sides. We end up with x equals 13. Again, we get a positive and negative version. However, we want the positive version because our final result makes sense for it to be positive because we're looking at lengths and measurements. So we end up with the hypotenuse is a measurement of 13. All right, great. Now, just some quick things to discuss again. The Pythagorean theorem is the square of the hypotenuse is equal to the sum of the square of the legs. Or you can think of it as the sum of the square of the legs is equal to the square of the hypotenuse. If you would like to remember the thing that you learned your whole life, it is completely fine. As long as you realize that when you say a squared plus b squared equals c squared, c has to be the hypotenuse. And the reason that I try to steer people away from that is because sometimes it makes sense for us to define one of the legs as c. And now people's formula or equation they've always remembered the whole life, they usually get the wrong answer. So I would stay to doing leg 1 squared plus leg 2 squared equals hypotenuse squared, or hypotenuse squared equals leg squared plus leg squared. However you want to do that, I feel like that would be much more useful for you and better for you, because it would prevent you from ever making the mistake of misplacing A, B, or C in the wrong space. Okay. If you can remember though that C is always the hypotenuse, A and B are always the legs when doing that, that's fine. So another thing that I want you to realize is, and many of you probably already do, is that there are some numbers that always go together whenever we're doing a Pythagorean theorem. For instance, if we have 3, 4, and 5, 5 would be the hypotenuse, 3 and 4 would be the legs. That is always going to work for a right triangle. If you have a triangle like that, it's going to have to be right because it works with the Pythagorean theorem. So if I have 3 numbers and I plug it into the Pythagorean theorem and it works, it has to be a right triangle. So, for example here, let's say I was given, let me erase this here. So let's say I was given, we've actually looked at 3 already. We've looked at 3, 4, 5. And we've also looked at 5, 12, 13. But let's say we have 7, 24, and 25. Let's see if that works. Let's see if that is going to form a right angle, meaning it's going to be a right triangle. Well, which one of these would have to be the hypotenuse? By definition, the hypotenuse is the longest side of a right triangle. Therefore, 25 must be the hypotenuse. So, if we were to plug this into Pythagorean theorem, we would get 7 squared plus 24 squared equals 25 squared. Okay? So 7 squared will give us 49. 24 squared will give us 576. And 25 squared will give us 625. Okay? Now, if you need to put those into the calculator to see if I'm telling the truth or not, go ahead. All right. So let's add these two things together. When I add them together, I end up getting 625 equals 625. So this does work. 7, 24, and 25 will form a right triangle. And you actually probably could draw it from here because you know that, hey, from my right angle, one side has to be 7, the other has to be 24, because the hypotenuse has to be the longest side of 25. Okay? These are called Pythagorean triples. The most common one used is 3, 4, 5. So throughout your time in your lessons, you may see a couple of these and you may say, oh, I know that that's going to be a right triangle. I just have to prove it on my test or my exam by showing my work that I know it. But I know it from off the top of my head. 3, 4, 5, 5, 12, 13, 7, 24, 25, and maybe tons of others that you'll learn are going to work. So yeah, that's the Pythagorean theorem. If in some case when you take the square root, you don't get a whole number, guess what? That's fine. That happens. You would most likely be asked to estimate or round it to a certain point based on significant figures or just based off a certain numerical place value. So that's Pythagorean theorem. The square of the hypotenuse is equal to the sum of the square of the legs, or the sum of the square of the legs is equal to the square of the hypotenuse. That's Pythagorean theorem. I will see you soon.